Hello, welcome to this section of Mastering Statistics. In the last section, we introduced the concept of the variance, the sample variance that you calculate when you have a collection of samples there, and the population variance, which is what you would calculate if you knew every single value in the population, which is a large collection usually. Most of the time you can't calculate the population variance because the population is too big, but there is an equation there if you need it. So in this case, what we're going to do in this lesson is practice that and just give you an idea. So if I wanted to calculate the sample variance, so I say find the sample variance of the following things, then how would we do that? Let me look and change colors a little bit and say our data set is 5, 8, 7, 6, and 9. All right, and so what we want to do is find that we want to find that sample variance. So because it's a sample variance, this is a very small set of samples, then what you use is the S squared equation. It's the sum of all of these little deviations about the mean, but we square each one, right, before we do any summing, and then we divide by n minus 1. In this case, n, the number of samples, is 5. So on the bottom we'll have 5 minus 1. Now before we can do anything, we know we're going to need to find the mean, because every data point is subtracting the mean from it. So what we'll do is just kind of go off to the side and do that right now. The mean is, for a sample mean, we already have done this before, 5 plus 8 plus 7 plus 6 plus 9. And there are 1, 2, 3, 4, 5 values, so we divide by 5. And what we'll get when we add up the top is 35 over 5, which is 7. So the mean is actually 7. All right? So then it becomes a matter of just substituting in and making sure you don't make any mistakes. My advice when you're calculating the variance, since there's a lot of numbers, is don't skip any steps. Write everything down, take time to simplify it and simplify it. Don't try to do too many things in advance because you're probably going to make an error. So the way I write it is like this. I'll open up a parentheses and I'll say, okay, the first point, notice the way the equation's written. It's the data point minus the mean. The first data point is 5 minus the mean. The mean is going to always be 7, so I'll write it as 5 minus 7, and then I have to square it because that's what we're doing here. The next point is 8, so I'll open up another parentheses and say 8 minus 7, because in all cases I'm subtracting the same mean. I got to square that guy. And then the third data point is 7 minus the mean, which is 7, and that's going to be squared. And then the next one is going to be 6 minus 7, because that's that data point right there. And then the final one is 9, so it'll be 9 minus 7, and I'll square that one off at the end. So I have kind of on the numerator here, I'm adding up 5 things. Each little nugget here corresponds to a point. This is the data point minus the mean. This is the data point minus the mean. This is the data point minus the mean. You do that for all of the data points. After the subtraction, you square it, and that's why the squaring is on the outside of the parentheses. Now notice, I know that all of you know that 7 minus 7 is 0. I know that all of you know that 8 minus 7 is 1. I know that all of you know that you can figure out what all of these points are. But notice I didn't do that addition or subtraction in my head. I write it all down because when you have a large number of data points, you're probably going to make an error at some point just because you get tired or whatever. And as a teacher, you need to be able to see that the student knows what they're doing. So by writing it all out, I can see exactly what you meant to do, even if you make a mistake. So on the bottom is going to be n minus 1. N is the number of data points.